Hi, this is the lesson for 11.5 volumes of prisms and cylinders. One of the things that we're going to be looking at in this lesson is how can you find the volume of a three-dimensional solid, where the base is a commonly known shape as a rectangle, a square, or even a circle, which in this case will become the cylinder. Now, we know from prior knowledge that the volume of a prism is the area of its base multiplied by the height of the figure. Now, depending on what kind of figure you have will depend on what this capital B might be. If the base is a triangle, we're going to use 1/2 times the base times the height, sorry. If it's a square, it's going to be a side length square. If it's a rectangle, length times width. And in this case, if it's a right cylinder, then we're going to use the area for the equation of the circle for the area of the base. So this B, it all depends on what the base is going to be. For example, here, you can see that you have a square stack of papers, and the papers are 2 inches by 2 inches, and it has a height of 8 inches. In this example, it's the same amount of papers, it's just kind of twisted. Now, if these stack of papers were to be tilted to the side, it would have the same volume because it'll have the same base, and it'll have the same area, and the height will be the same. This is called Cavaliers principle. Okay, so even if your figure is tilted, we're still going to use the same equation pretty much. So for this problem, the volume is the area of the base multiplied by the height of the prism. Now, don't get confused with this height because sometimes your triangle, if you have a base that's a triangle, it's going to have its own height. So you're going to have two heights to deal with, the height of the triangle and the height of the prism itself. This h represents the height of the prism. Now, because the area of the base happens to be a square, we're going to use side length square times the height of the prism. That side length, by the way, that's an S. Let me put a little line through it. Represents the side length because this is indeed a square, and the side length happens to be 2. 2 quantity square multiplied by 8. Now, 2 squared, that's 4, and 4 times 8 is obviously 32. So the volume of this is going to be 32 inches cubed because, of course, we know that units of volume is in cubes. And by the way, this is on page 334. So let's turn to page 335. Now we're going to eliminate these two examples because we're going to be doing them in the examples anyways. So on page 335, this is where you're going to be putting examples 1 and examples 2 on 335. Turn the page to 336. And here's where we are going to be putting example 3 and 4 right at the top, example 5 at the bottom. And once again, like we talked about already, the volume of a prism is the area of the base. Depending on what the base is will depend on what independent equation that's going to be, and the height of the prism. Example 5 goes right there. And as you can see, these two prisms are the same prism, except for this one is just tilted. But one of the things that you have to be really careful is that the height of this prism, because it's a right prism, is this distance right here. But when you tilt it, this height is now a slant height. It is no longer the altitude of the prism. So the distance from here to here is going to be the new height. So we have to be really careful with that because we don't want to say that the height of this is the distance from here to here. In order for something to be considered a height, it has to be perpendicular to the base. Here, this side length is perpendicular to the base, but here, this side length right here is not perpendicular to the base, it's at an angle. So this will be the altitude. Now, when you tilt it on the side, this length will change, but the height won't. Now on page 337, we are going to be putting problem 6 right there and problem 7 right here. Now, the equation for the volume of a prism is used to derive the volume of the cylinder. Now, the only difference between a prism and a cylinder is that it has some type of curvature, but the area of the base, it's only specifically one equation, and that's pi r squared. So pi r squared times the height is the equation for the volume of a cylinder. Now, one of the things that we have covered in the past with similar solids is when you guys had two shapes that we said that they were similar. Okay, remember that the scale factor of the length, we figured that out by finding the ratio of the image to the pre-image. Now that happened to be equal to the scale factor of the perimeter. Okay, I should say scale factor of the length is equal to the scale factor of the perimeter. Now, when we talked about the scale factor of the area, it was the scale factor of the lengths or the perimeter quantity square. Now, for this lesson, we're going to be dealing with the scale factor of the volume. Okay, so if we were to go ahead and find the scale factor of the volume and compare that to the scale factor of the length, we're going to notice that that's equivalent to the scale factor of the length quantity cubed. So when we get to that problem, it'll make probably a little bit more sense. And that is what we're going to do example number 7. So let's go ahead and move on to the examples. Okay, here's example number 1. It has two parts to it. It says find the volume of each prism. Now remember, the volume of a prism is equal to the area of the base multiplied by the height of the prism. Now the base happens to be a right triangle, so any of these lengths can act as an altitude. So to find the area of the base, you simply have to multiply length times width. This length right here is the same as this one, and this length right here is the same as this one. So the area of this triangle, we know that the area of the triangle is the base times the height divided by 2. This height is not the same as this height, and this base is representative of this length right here. So that's going to equal 3 multiplied by 4 divided by 2. So 3 multiplied by 4 divided by 2, that gives me that area. 3 times 4 is 12. 12 divided by 2, that is equal to 6. Now, the height of the prism, it's given right here as 2 centimeters. So now that you have both pieces of information, you may now calculate what the volume is. So the area of the base, which happens to be 6, and then multiplied by the height of the prism, which happens to be 2. So the volume is 12, and I'm going to bring back the units, centimeters cubed. So like I said, this equation for B will change depending on what your base is. So how do you know which one's your base? If you look at this triangle right here, imagine trying to do a cross-sectional area like we did in the previous lesson. If you were to slice this triangle vertically, you can see that the shape that is being created as you keep slicing it vertically, it's not going to give you the same shape. However, if you were to slice this horizontally, you're going to notice that this cross-sectional area is the same as the one at the bottom and the one at the top. That is how you know which one is your base, because sometimes it could be a little confusing. For example, on this one, if I were to do a vertical cut right here, the shape created here will not be the same as the shape created right here. However, if I were to cut this horizontally, okay, this shape right here will be the same as the one at the bottom and the one on top. So this right here is the base. So the volume is the area of the base multiplied by the height. So what is the base? The base in this case is a trapezoid. How do you find the area of a trapezoid? Well, back from chapter 7, we learned that the area of a trapezoid is simply the sum of the bases multiplied by the height of the trapezoid and then divided by 2. So let's identify what every single one of these things is going to be. Now, for just the trapezoid, the bottom base right here happens to be 14, so that's base 1. The top base, this one, is the same as this one, so that is going to be 6. The altitude of the trapezoid is this right here, 3 centimeters. How do I know? Because of that right angle. So 3, and then divided by 2. So now I need to calculate what that area of the base is going to be. 14 plus 6, that gives you 20. 20 times 3 divided by 2, that reduces to give me a 10, and that gives me a result of 30. So the base is 30. Now the height of the trapezoid, the trapezoidal prism, happens to be 5. So now all we got to do is simply find the volume by multiplying these two values together. So 30 times 5, that's going to give me 150, bringing back my units, centimeters cubed. If you want some extra time to copy these, pause the video so you can copy them. Let's look at example number 2. It says, find the volume of each cylinder. So we know that the volume of a cylinder is the area of the base, pi r squared, multiplied by the height of the cylinder. The radius in this case is 9, and the height of the cylinder is 6. So all we have to do is just literally plug things in. Pi 9 square, times 6. So I'm going to give you two answers. So I'm going to give you the exact answer and then the approximation. So 9 squared, that's 81, and then times 6. So now what we need to do is we need to multiply 81 times 6, and that gives me 484 pi. Now, if I want an approximation, all I have to do is multiply this value by pi, and according to my calculator, to the nearest tenth, this is 1,526.8 units feet cubed. Physicists always have to have units. It's their thing. Math people, sometimes we're a little careless, but it's important to know your units. Now, for part B, the area of the base, that will be this one, and the height is not this length right here. The height is the distance from here perpendicular to the bottom, which is actually given to us to be 7 centimeters. So the volume, pi r squared times the height, make my pi's look better. Okay, so pi r squared, 4 squared, multiply by the height of 7. So that's going to be 16 pi times 7. The volume would be 112 pi units centimeter cubed. Now, if they want an approximate answer, all I have to do is just type that into the calculator, multiply by pi, or 3.14, and to the nearest tenth, that's going to be 351.9 centimeters cubed. So if they're asking you for the exact area, you type this in. If they're asking you for the approximate area, use this one. Always pay attention to how they want you to round. And this is number 2. Let's look at number 3. In this problem, we're going to be talking about density. So we're going to get into a little bit of science. The diagram shows the dimensions of a standard gold bar of Fort Knox. Gold has a density of 19.3 grams per cubic centimeters. Find the mass of the standard gold to the nearest gram. So our issue here is that everything here is in terms of inches. So what we got to do is we need to make a couple of conversions. So in order to make those conversions, we need to know a couple of things. The first thing, 1 inch is the equivalent to 254, nope, no, that's too much, 2.54 centimeters. And we also need to know the equation for density. Now, density is the mass of the object divided by its volume. Okay, so in this case, we are given this 19.3 to be this one. We can calculate the volume, and then all we have to do is find out the mass. Okay, so let's go ahead and convert this. Now, to find the volume of this figure, we would have to multiply the area of the base times the height. So this is going to be 7 inches multiplied by 3.625 inches multiplied by, that's the area of the base, by the way, 1.75 inches. So there's multiple ways to do this. You can find the volume as is and then make the conversion in terms of volume, or simply do the change right now and then figure out your calculation. So I'm going to convert this into centimeters. How am I going to do that? Well, if 1 inch is 2.5 centimeters, I have to multiply every single one of these by 2.54, every single one of them. So this is going to be 7 multiplied by 2.54. That's going to be in centimeters. I have to multiply this to 2.54 centimeters, and I have to multiply this times 2.54 centimeters. Why do I keep going back between X's and dots? I have no idea. Okay, so let's just go ahead and multiply these in steps. 2.54 multiplied by 7. That gives me this much. Now I'm going to drop the units for right now, mainly because I want to worry about the numbers. I know at the end it's going to be centimeters cubed. Okay, 3.625 times 2.54 and 1.75 times 2.54 and this is going to be centimeters cubed. So now what I need to do is I need to multiply all 3 of these values. Yes, it's a lot of multiplication, but aren't you glad you have a calculator? I am, unless you want to multiply all this by hand. Which if you do, you get extra cool points, by the way. All right, so I get this really huge number. Okay, so I'm going to be doing a little bit of rounding, by the way. So that's going to be 727.69. The difference at the end is not going to be that much because we're going to round to the nearest gram. So centimeters cubed. Now that's the volume. That's not the answer, but that is the volume. That's this one right here. We already know this one. All we got to do is solve for the mass. So let's substitute the values in now. For the density, that's 19.3. The mass, that's unknown. Now I'm leaving out the values, the units you would say, but we know it's going to be in grams. And this is going to be 727.69. So when I cross multiply, I'm going to get the mass to be about 14,044 grams. So this is the mass of this. Now, how much is it worth in real money? Because this is gold, I have no idea. That'd be something interesting to look at. And that's example 3. Let's take a look at example 4. Example 4, you are building a rectangular chest. You want the length to be 6 feet, the width to be 4 feet, and the volume to be 72 cubic feet. What should the height be? Well, we know that the volume of this prism is the area of the base multiplied by the height. Now, the area of the base is rectangular, so 6 times 4, and the height is unknown. But we do know that the volume is going to be 72. So we're going to replace that 72. 6 times 4, that's 24 times h. So what we're going to need to do is we're going to need to divide both sides by 24. And the height is going to be 72 divided by 24. And I get exactly 3. So the height of this test is going to be exactly 3. Example 5. You are building a 6-foot tall dresser. You want the volume to be 36 cubic feet. What should the area of the base be? And get possible lengths and widths. So we know that the volume is equal to the area of the base times the height. Now we don't know what dimensions the base is going to be, but we do know that the volume is going to be 36 and the height is going to be 6. If you solve for the area of the base, that's going to give you 6. So it is rectangular or maybe square, who knows. Now, depending on what they want, if they're okay with, half values, there's an infinite amount of values that you could put. The best choice here would be 2 feet by 3 feet because that would result in the area to be 6. Now you could do a 1 foot by 6 foot, but come on, who wants to have a dresser that is only 1 foot wide? It makes more sense to have a 2 by 3 feet. So if I were you, this would be the best choice for that dresser. And that's number 5. Now, number 6 might be a little complicated, but I am being asked to find the volume of cylinder B. Now, one of the things that we do know is that these are similar solids. So we need to remember what we remember about areas and lengths. If you remember, K represented the scale factor of the lengths, and K squared represented the scale factor of the areas. And in this case, K to the third represents the scale factor of the volumes. So we need to go ahead and find out what the heck is K going to be. So a proportional side to both of these is the radius. Now you have to decide which one's your image and which one's your pre-image. If they don't tell you which one is which, then you decide. So I'm going to make this one here my pre-image and this one my image. So 6 is the length of the radius, 3 is the length of the radius. So my scale factor is going to be 6 to 3. That reduces to 2. So K equals 2. So the question is now, what is K to the third? Well, that's simple. That's 2 to the third. 2 to the third, that is equal to 8, but we're going to need to put it over 1 for the sake of the proportion we're about to make. Now, this is the ratio of the volumes, the volume of this one to the volume of this one. This is the one that we don't know. That's my unknown. We know this one. So I know that the scale factor of the volumes would be whatever volume that is over the volume of cylinder A, which is 45 pi. Now, if I knew what volume of V was, then I know that would reduce to this scale factor, a to the third, which is 8 over 1. So now you're going to cross multiply, and you're going to get 8 times 45. And that's going to give me 360 pi. Now, the exact answer in terms of decimal is going to be 1130.97, or if I want to round this to the nearest, what is it called, centimeter, then it will be 1131 centimeters cubed. So it all depends what answer they want. They want the exact answer, that's your answer. They want approximate answer, that's your answer. The biggest mistake people do is here at this step. They forget to cube. Now, sometimes they're going to give you some problems where they're going to be dealing with the area, and you have to figure out what K is, and then you have to figure out what K to the third is. It's like a puzzle. And that's number 6. Now, the last problem is a little bit more involved because it wants to find the volume of the concrete block. Now, what we need to do first is we need to find the area of the top face. The top face and the bottom face, it's pretty much the same thing. This thing is hollow. So if I look at the top dimensions, I'm going to redraw it right here. Okay. Now, how long is this? This is 1.31 feet. What's the length of this? That is 0.66 feet. And it has 2 rectangles. Now, these rectangles have the same dimensions. So the dimensions are 0.33 and 0.39. And it's the same for this one. So what we need to do is find the area of this figure right here. So to figure out that area, we have to figure out the area of the rectangle and then subtract the area of 2 of these. So the area of the bottom is going to be the area of the rectangle minus 2 times the area of the small rectangles. So that's what we're trying to do. Now the area of the whole rectangle is 1.31 multiplied by 0.66 minus 2 times the area of this small square, not square, rectangle. That's 0.33 times 0.39. So it's all in the calculator. So 1.31 times 0.66. 0.33 times 0.39. Now, when I multiply that by 2, I get the following. A lot of decimals, guys. Okay, let me clear that again. 0.1287 times 2 That is 0.2574. Okay, subtract that from 0.8646. And the area of the base is 0.6072. So that's this area of the base right there. So now the height of that prism, in this case, is 0.66. So to find the volume, I have to multiply 0.6072 and 0.66. Okay, so times 0.66. I get the volume to be about 0.400752. However, they want the area, the volume, not really sure. Cubic feet. As a matter of fact, I actually just looked up the answer, and this is how they want you to round it. About 0.4 cubic feet. Now, don't forget to do your extra practice on your lesson 11.5. Don't forget to do the online homework as well. All right, have a good day, guys. See you later.